In this video, we're going to do a conservation of momentum problem with an inelastic collision with two carts. So we have a cart of mass 0.51 kilograms moving on a horizontal track at 2.20 meters per second toward a stationary cart of mass 0.56 kilograms. If the two carts stick together after colliding, what is the magnitude and direction of their velocity after the collision? So let's look at this problem and figure out what we know first. So we have two carts here. We have the first one that has a mass, we'll call this mass 1, of 0.51 kilograms, and then the second mass is 0.56 kilograms. We know that this first cart is moving with a velocity we're going to call v initial 1. So this is mass 1. Its velocity, its initial velocity is 2.20 meters per second. And we know the initial velocity of the second cart is 0 because it's stationary. So v initial for cart 2 is just 0 meters per second. And then they're going to collide and stick together, and we want to know their velocity afterwards. So if they're sticking together, they have the same final velocity. So in our second part here, we have these two carts, and now they are moving together after they collide. So we just have a velocity we're just going to call v final. And the masses are still the same, but we have a total mass of m1 plus m2. So now we can kind of think of it as one object of mass m1 plus s, or m1 plus m2. So what we want to do here is just conservation of momentum. Similar to conservation of energy, where the initial total momentum is going to equal the final total momentum, where this is the first situation and this is the second. So initially, we have the momentum of the two carts. They have a separate momentum. So we have momentum of the first cart initially plus the momentum of the second cart. So P initial 2. This has to equal the total momentum in part 2, which is going to be P of, so the combined momentum of the two carts, P12, and this is the final momentum. We'll call it PF12. So the momentum is going to be equal to the mass times the velocity in general. So this is the final, so initial and final. So in the first part, we have the initial momentum of cart 1. That's just going to be the mass of 1 times v initial 1. And then the mass of 2 times the initial velocity of the second cart, which is 0. And then that's going to equal the final momentum of the two carts moving together, which is now going to be m1 plus m2, so their total mass, times the velocity that they're moving at together, so v final. Now, as we said, this second term here, m2 times v initial 2, is just 0 because the velocity is 0. So really what we have is m1 times v initial 1 equals m1 plus m2 times the final velocity. So let's just go ahead and solve for the final velocity by dividing both sides by m1 plus m2. So that's going to give us v final is equal to m1 times v initial 1 divided by m1 plus m2. So we can just go ahead and plug in the values that we have here. So m1 is 0.51 kilograms times v initial 1, that's 2.20 meters per second, divided by m1 plus m2, 0.51 kilograms plus 0.56 kilograms. And that is going to give us a final velocity of 1.05 meters per second. So it's slowed down because we now are combining the momentums of the two blocks, where we initially had 2.20 for the first one and then 0 for the second one. So because of that second cart, the final momentum is going to be less when we have the greater mass. Now, in a different situation where the two blocks are moving towards each other initially, so both carts are moving, then we may end up with a velocity, a final velocity that is negative, and that would just mean that they're moving together in the opposite direction. But because the second block was not moving, we do still have a final velocity that's positive, meaning that it's just going in the positive x direction. So they're still moving toward the right, but at a slower speed than the first cart was initially moving. So hopefully that was helpful. I will probably post some more conservation of momentum problems that are slightly more complicated. We'll go ahead and look out for those, and let me know if there's anything else you guys would like to see. Thanks for watching.